Problem number 8 on the spring 2015 exam says transform the integral into an integration by parts integral, and it gives you this to start with, 1 over e to the square root of x dx. So in this case, it tells you exactly what it wants you to do. It says just transform it using some sort of substitution, but then all you have to do is just leave it. You don't have to actually solve it out. So let's take a look at this integral. So I have 1 over e to the square root of x dx. Okay, so when I see something like that, what kind of stands out to me is, again, I need to make some sort of substitution here to make this work. Well, when I have e to a power like that, usually what I want to do is I want to try to start with that power to make it a little bit easier. Now, if I look at all my answers, they all have e to the u or e to the negative u over 2 or something like that. So starting with u equals square root of x is probably a good place to kind of look at it initially. So I have this substitution right away, but the problem is now I need to come up with a substitution for dx. Well, if I go ahead and take the derivative of this, du is equal to 1 over 2 square root of x dx. I don't have this term in my integrand. So this doesn't help me. This substitution isn't going to work unless if there was a 1 over 2 square root of x somewhere in there, then it would have worked perfectly. But in this case, it looks like it doesn't work. So I can't do this substitution. At least not in that form. Remember, what you can always do, though, is with u substitution, you can manipulate this top equation however you want. You just can't really do much to the du term. You can only really kind of multiply and divide by constants. But here, I could square, add, subtract. I can do whatever I want, really. So what I'm going to do, I'm going to square both sides. U squared is equal to x. So I still have a definition for square root of x. That hasn't changed. But now all I've done is I've just taken my substitution and squared it. And now what I can do is I can take the derivative of this. So I end up with 2u du is equal to dx. Well, okay, so that actually helps me in this case. So now what I've done is I've basically said that 2u du is equal to dx. Now, is there a way to get that from the other substitution that we had? So remember, initially we had du was equal to 1 over square root of x dx. Well, it turns out that this and this are actually equivalent. If I want to get just dx by itself, if I just multiply this term over, I have 2 square root of x du equals dx. And now, this needs to be in terms of u if I'm going to multiply it by du. So I use my substitution, and I end up getting 2u du is equal to dx. So, this substitution would have worked either way. But in this case, what I did was by squaring it, I ended up with the same result. So you can do it either way that you feel comfortable with, and whichever way that you think you're going to remember more on an exam. In this case, I'm going to stick with this one because this is the way that I was usually taught to solve these. So I have the 2u du is equal to dx, and I have u equals square root of x. So I have my substitutions that I need. I have 1 over e to the u times 2u du. Okay, so now that's pretty much where I'm stopping in that case. The one thing I notice is that the e to the u is not on the bottom for any of the terms, so I'm going to bring it up. And by doing that, I end up with 2u e to the negative u du. So now I look and see if that matches any of my terms, and it does. It matches letter E. So this is my final answer, and letter E is the correct answer on the exam.
The Teaching Center, UF's Learning Resource Center.